Hey guys, Ben here, 3dgladiator.com, and in this video I'm gonna teach you how to use ZBrush. So ZBrush is a digital sculpting application that is used by many studios all over the world to create 3D characters and 3D assets. And I'm pretty sure that you already know what can be achieved in ZBrush, but you maybe don't know what it takes to create these amazing artworks. And that's exactly what I'm gonna change in this video. At the end of this introduction, you will have an in-depth understanding on how to create a project in ZBrush. You will know more about the basics than many other people do, and you will have laid a solid foundation for your future learning process. So why should you spend the next 2 hours with me? So first of all, this is not a sponsored tutorial. I use ZBrush for more than 15 years now and started with version 1.5 back in 2003. So basically I have witnessed how Pixologic, that's the company behind ZBrush, has turned the software from an interesting piece of concept into a fully fledged workhorse. And I can guarantee that when it comes to poly modeling, there is almost nothing that cannot be done in ZBrush. But I still see many people are struggling with the basics, and this is totally unnecessary. That's basically because if you start the wrong way, you become frustrated pretty fast and you do not stick long enough to see first results. So if you watch this video until the end, we will overcome these initial obstacles once and for all. So let me make this very clear. This is a complete beginner tutorial. So it doesn't matter what your background is. You maybe already have some experience with another 3D application, or ZBrush is the first 3D program that you learn. It doesn't matter because we start at the very beginning. And even if you know already something about the basics, I recommend that you keep watching because you probably got things wrong. So I've broken this thing down into 5 parts. In part 1, we will take a look at the technical background of ZBrush. We will take a look at poly modeling and the 2.5D concept. In part 2, we will download, install, and launch ZBrush for the first time, and I give you a brief introduction on the navigation and the user interface. In part 3, we will cover everything that you need to know about poly modeling in ZBrush. In part 4, we will take a look at several different workflows. And in part 5, we will combine everything that you have just learned and start creating a sample model. The seagull model I've created for this tutorial, so that's the little bird on my second screen here in the background, is inspired by a character from the Disney show The Puppy Dog Paws. It is also based on a concept drawing by the amazing Jeremiah Alcorn. I do not own any copyrights on the model or the drawing, and I haven't contributed anything to the show or worked for Disney, so all rights exclusively belong to Disney. I've also linked the show in the description below, and I highly recommend that you guys visit Jeremiah's Instagram profile for more great concept drawings. The link is in the description too. Before we continue, I would like to talk about some common misconceptions you can find all over the internet when you do your research on how to learn ZBrush. So let me quickly switch over to my whiteboard and clear a few things up for you guys. The first point on my list is ZBrush is hard to learn. So let me quickly note this on the whiteboard. Point 1, hard to learn, right? So I think that this is not true at all. ZBrush is not much harder to learn than any other 3D application like 3ds Max or Maya or Blender, for instance. Of course, at the beginning it takes some time and practice to get used to the tools and the workflows, but this becomes second nature pretty fast. I want you to be aware of 2 important things here though. The first one is that you have to distinguish between ZBrush as a tool on one side and the craft of sculpting, or let's say traditional or digital sculpting, on the other side. These are 2 separate skill sets. So with the right instructions, you can pick up ZBrush and learn it in a couple of weeks with ease. But mastering the craft of sculpting, that's pretty much a never-ending story and takes years. And to unleash the real power in ZBrush, you have to combine both skills. So let's say if you are already an experienced traditional sculptor, then you can pick up ZBrush in a few days and start transferring the great work that you are already creating into a digital environment. If you do not have these traditional sculpting skills, then of course you can still learn ZBrush as a tool, but it takes additional efforts to learn sculpting skills. So picture this, it's pretty much like knowing how to use pen and paper. This does not mean that you know how to create a beautiful drawing, right? And it's the exact same thing in ZBrush. And still, the tools are so versatile that you can still come up with complex sculptures even if you have just started learning how to use ZBrush as a tool together with learning how to sculpt, right? So not knowing how to sculpt shouldn't be a reason not to start learning how to use the tool. The second thing is about your input device, which is probably still an ordinary mouse. So ZBrush relies heavily on the use of a graphic tablet because all of the brushes are pressure sensitive. And if you really want to dive deep into sculpting, you have to use a tablet, no matter what. This maybe sounds a little bit easier than it actually is. I remember that it took me more than a year to fully accustom myself to the tablet because I made the mistake on falling back on using a mouse again and again. So the fastest way to get used to the tablet is to simply unplug your mouse and store it away forever. I've even played games with pen and tablet and I would never ever switch back to a mouse again. So besides pressure sensitivity and an increase in work speed, it also has a relaxing effect on your arm and wrist, which allows you to work for long hours. When I talk about graphic tablets, I do not mean these crazy expensive Wacom Cintiqs, for instance, where you draw directly on the screen. I'm talking about any regular, small, simple graphic tablet. Point 2 on my list of misconceptions is that the ZBrush user interface is an unstructured mess. So let me note this also on the whiteboard. Point 2, UI for user interface is a mess. I especially hear this by people who are just starting out learning ZBrush. I've never heard that by someone who has mastered the program. And I think there's a pretty good reason why ZBrush looks different than any other application. And this is mainly because it is built around the sole purpose of tweaking geometry in the most intuitive way possible, without worrying too much about technical aspects of 3D modeling or polymodeling. You will notice why icons and elements are arranged in a certain way in ZBrush when we together take the first steps later on. And beside the different look of the user interface, it's also worth mentioning that you can customize pretty much everything. So you can rearrange all of the icons, you can assign shortcut keys to them, and this allows you to build your own very personal ZBrush user interface that perfectly fits your needs. Besides that, shortcut keys are essential in ZBrush. You control many functions and brush properties through shortcut keys. And it is true, there are a lot of them, and especially at the beginning it's quite difficult to memorize them all, so I recommend that you keep repeating them again and again until you don't have to think about which key combination belongs to which function. I've created a shortcut key cheat sheet which is available for download in the description. It does not only contain a list of shortcut keys, but also a brief summary of all of the topics I'm gonna cover in this tutorial. We will talk about shortcut keys in great detail when we take a look at the polymodeling tools in ZBrush. This leads us to point 3 on my list of misconceptions. ZBrush requires the latest hardware. So let me quickly note on my whiteboard, point 3, hardware hungry. Right? Of course, it is true that the more hardware power you have available, the better, and still the newest rig is not necessarily required. So keep in mind that ZBrush only uses your processing power and RAM. This means a fancy graphic card is not needed. When you deal with meshes that consist of millions and millions of polygons, like large 3D scans, ZBrush will eat up your resources pretty fast, no matter how much you have available. And for this exact reason, some initial planning is necessary. But if you plan your projects ahead at the beginning, pretty much every laptop or PC is sufficient to start working. So speaking about hardware, let me quickly bring up the graphics tablet issue again. So if you already use a graphic tablet, then great. If you have one but you don't use it, now it's the time to plug it in. And if you don't have one, don't worry, that's totally fine too. You don't need one at the very beginning. But like I've already mentioned, in the long run, you will definitely want one to take full advantage of the pressure sensitivity, right? So this means that you can apply brush strokes with different pressure sensitivity depending on how hard or how much you press the pen against the tablet. By getting some of these misconceptions out of the way, now it's time to take a look at a few technical principles. And first, let's talk about polymodeling, as this is what modeling in ZBrush actually is. Even if you can create these highly complex sculptures, at the end of the day, it's still plain and simple polymodeling. But the way how this is handled in ZBrush distinguishes it from any other application out there. So basically, ZBrush allows you a much more artistic and result-oriented approach than just moving points around in space. And besides that, ZBrush is also capable of handling millions and millions of polygons and still runs smoothly. So for this reason, let's take a look at what a polygon is. So generally speaking, a polygon is a closed figure formed by straight line segments on the same plane. So if I draw 3 points, point 1, 2 and 3, and connect them with straight line segments, I build the simplest polygon possible consisting of 3 sides. So this will be a 3-sided polygon. Of course, the same works with 4 points. So if I draw 4 points and connect them with straight line segments, I end up with a 4-sided polygon. And to give you another example, I can, for instance, also place 5 points, connect them again with straight line segments, and this will be then a 5-sided polygon, right? So if we expand on this principle and place our points in 3D space, so let me quickly draw a coordinate system like so. This is our x-axis, our y-axis, and if I extend this by an additional axis, this will be our z-axis. And when I now place points in space and connect them again with straight line segments, like so, I built a face in 3D space. And when I now add additional points and connect these points with the already existing points, and by keep doing so, I eventually end up with something that can be interpreted as a closed surface or a solid, even if it remains hollow inside. So by following this logic, the more polygons or faces or points a surface has, the smoother it appears. And this leads us to subdivision surfaces or subdivision modeling. So by subdividing a surface or adding more vertices or more points and faces to it, we will create a surface that is denser than the original one. So if I draw a 4-sided polygon again here, 1, 2, 3, 4, and connect it with straight line segments, and then divide each of these line segments by 2, so I introduce new points here and connect these points, I create a denser mesh than the original one. And if I keep doing this, the mesh gets denser and denser each time I subdivide it, right? And with a certain distance to the model, the surface appears to be smooth. So if I zoom in close to this one, I can still see the single polygon. So let me demonstrate this on a surface that's a little bit more complex. Let's say something like this. If it consists only of a few faces, let's say 1, 2, 3, 4, I'm not able to match this curve. But the more subdivisions I add to the surface, or the more points I introduce, or the more faces I introduce, the closer I get to this rounded surface here. And again, if I zoom in close to the surface, you can see all of the single polygons, and with some distance to it, the surface appears to be smooth. Depending on the calculation method, you can turn a box into a sphere-like shape this way. So let's say if we have a simple box and subdivide it a couple of times, we will eventually end up with something like this, depending on the calculation method and the amount of vertices or points we add. So before ZBrush has existed, this was kind of a painstaking process because you had to manually move the points or vertices around in 3D space, and then at the end you were applying some sort of smooth modifier to it to achieve a detailed and smooth result. But with ZBrush you can focus on the creative part without constantly worrying about technical aspects of polymodeling, right? So you focus on the creative part first, and when you are done sculpting, then you can still prepare the model for the later use in the pipeline. There is one more thing I would like to talk about before we finally jump into action, and this is a big one and an important one. It's the 2.5D concept ZBrush is based on. Yes, that's correct, 2.5D. Even if you will not use it, it is still omnipresent, and understanding the core principles of 2.5D will help you to understand why things are handled a little bit different in ZBrush than in other 3D applications. So it, for instance, explains why we have 3 different saving options, and it would also explain why 3D models are called tools. So let me quickly write down 2D, 2.5D, and 3D. We have 2D at the very top, 3D at the bottom, and as the name already implies, 2.5D is a mixture between 2D and 3D. So it is located somewhere in the middle here, and I note 2.5D here. And let's start with the explanation of 2D, or a two-dimensional pixel first. A pixel is short for picture element, and it's basically the smallest building block of an image. So if I draw a coordinate system here again, I can start placing two-dimensional pixels on this grid, right? So I simply place them here. And every pixel contains or stores information about its position in the grid, and additional information like color values, for instance, red, green, and blue, right? And in consequence, the more pixels an image has, the higher its resolution. On the other hand, we have our 3D concept. So I draw the coordinate system again. This is our x-axis, our y-axis, and I now extend the two-dimensional grid by a third axis, which is our z-axis. And now I can start placing 3D models in this coordinate system, like so. And as you already know, the 3D model here is built by vertices or points in 3D space that are connected with straight line segments, right? And in this case, I can rotate the model around in the viewport or in 3D space, and I can also rotate the camera around the model. So this is my camera, and I can rotate it basically around the model here. So Pixelogic has taken the 2.5D concept one step further. They do not store only color and position information into the pixel, they also store depth information, orientation, and material information. Right? So it's a pixel on steroids, so to speak, and they do not call it pixel anymore, they call it pixel. So they've changed the term from pixel to pixel, right? And I guess this is also where the company name Pixologic comes from. So what does this mean in practice? We still have a coordinate system that consists of a y and an x-axis, like so. This is our x-axis and our y-axis. And because we are now applying brush strokes or pixels to the canvas with a brush, and we do not only apply position and color information, but also depth, orientation and material, the coordinate system, or the canvas as it is called in ZBrush, gets virtually extended by a z-axis. So we have a z-axis here, and every time I draw a brush stroke to the canvas, I apply also depth information, right? So let's say I have an object here, or a 3D primitive that is placed on the canvas. Then it appears to be some sort of 3D, right? We have a highlight here, we have a shadow side over here, and let's say the light is coming from here, and because orientation is stored into the pixels, I can move the light around and let it shine from here, and in this case also the shading or the position of the highlight and the position of the shadows, they react according to the position of the light, right? And I can now switch between different 2.5D brushes and start modifying the pixels. I can apply different materials, I can change the colors, and I can also move the pixels or pull the pixels out or push them in closer to the canvas until they literally disappear behind the canvas, because depth information is stored into them. But keep in mind that we are still not dealing with a real 3D object here, because I cannot rotate this object because the pixels are fixated to the canvas. I cannot also not rotate the camera around it because of the same reason, right? The pixels are fixated to the canvas. And because I'm editing the depth value along the z-axis with a brush, the application is called ZBrush. That's all you need to know for the moment. In the next part, I will show you what all of this looks like in action. But before we can use ZBrush, it's a good idea to install the software on your computer. Alright guys, so before we can start ZBrush, we have to download and install it, of course, and you can find ZBrush on the Pixologic website on pixologic.com. And if I click on Get ZBrush, you have several options here. Let's start with Buy ZBrush. And you can buy ZBrush 2019 as a monthly subscription, or if you are not a fan of the subscription model, you can buy it also as a perpetual license. And the price is still fantastic for the amount of features that you get. And besides buying the regular version of ZBrush, you have also the possibility to get ZBrush Core. It is available in the 2018 version at the time I'm recording this video. And as you can see, the price is a lot lower than for the standard license. And that's because a few features are missing. So if we check the feature comparison list here, you will notice that not a lot is missing. We have Dynamesh, we have ZSpheres. The maximum number of polygons per mesh is limited to 20 millions, which is still more than enough to create highly complex and detailed models. Live booleans are missing, and Sculptris Pro is missing too, for instance. But still, ZBrush Core is a great deal to start learning. And the sample model from the introduction, for instance, can be also easily recreated in ZBrush Core, right? And then, of course, we have also the option to try ZBrush. The trial version is currently available as ZBrush 2018. And all you have to do is register on the Pixologic website, download the package, and connect to the internet every time you launch ZBrush, right? I am working with the latest version, and that's 2019.1.2. So if you come from the future, All of the concepts I share in this tutorial should still be relevant as long as Pixologic does not change the core of the software. So don't worry if you watch this in 2022, the basic concepts will still be the same. So this is what you will eventually end up with after a clean installation of ZBrush. And before we take a look at the user interface, I would like to show you my tablet settings. I am using a Wacom Intuos Pro. It's not the newest model, but it still does the trick. So if you consider buying a tablet, look on eBay first, because people are selling tablets that are pretty much unused and you can get them for a very good price there. So my tablet settings are available in the control panel here under Wacom tablet properties, and then this little window pops up. And I've set the tip feel from the middle position here slightly to the left to make the brush a little bit more pressure sensitive, and I don't have to press it that much against the tablet, right? And then we have, of course, our standard left click set to the tip of the brush. I've set the right click to the first button and the middle click to the second button here. For the eraser, I've left the settings untouched, and for the mapping, I've set this to full screen, of course, to control both of my screens. And I've also adjusted the tablet area and set it to portion. And these settings really depend on the size of your tablet in combination with the amount of screens and of course also the screen resolution. So adjusting these values basically controls how fast the cursor moves across the screen, right? So it requires some testing here to find the perfect values for you. Then last but not least, I've set the express keys to the right. The express keys are these little buttons on the tablet here. And I've set them to the right because I use the tablet in the position of my mouse. So I don't have it in front of the keyboard like many other people do. I have it next to it where you would usually have your mouse. And I've set them to the right so I can move my hand over to the keyboard without touching the express keys. So I don't use the express keys, and now I can move the hand over without accidentally touching them, right? And I have disabled all of the touch features of the tablet because they are pretty much useless. And that's pretty much it. You are good to go with these settings. Alright, then let's jump back to ZBrush and give you a brief introduction on the user interface. So when you launch ZBrush for the first time, you will get prompted with this built-in browser. It is called Lightbox, and it gives you quick access to your projects, tools, brushes, alphas, and much more. And you can open and close the browser by hitting the Lightbox button or the little hide button over here. And of course there also exists a shortcut key to open and close Lightbox, and that's the comma key on your keyboard, right? And in the preference settings here, if you open up the preference palette and go down to the Lightbox settings, there is a button that tells ZBrush not to open Lightbox at launch. So if you disable it, it should not open when you start ZBrush the next time. For some reason this does not work on my end, but you should give it a try, maybe it works for you. Then we have our canvas in the middle of the screen. This is where all the action takes place. We have a drop-down menu where all the tools in ZBrush are stored. And we have a left and a right tray that I can open up or close by double-clicking on these little arrow icons here. And you can basically store all of the palettes in these trays by hovering over the title, and then just simply drag and drop this little circle icon over to the left or the right tray and release it above the tray. And to keep everything nice and organized, you can click on the title to close it or open it again. And when you click on the little circle icon, you remove it from the tray. So keep in mind that the palette is still accessible through the drop-down menu. Next to the canvas, we have all of these tools. And I want to point out that these are not special tool palettes, because everything you see here, all these buttons and switches, they also can be found in the drop-down menu, right? So let me quickly demonstrate that by docking the document palette over to the right tray. And if I hover over these guys next to the canvas, you can see that they are also get highlighted in the document palette, and that's because these are actually one and the same buttons, right? So I'm able to move the canvas around by clicking on the scroll button and set it back to the center of the screen by clicking on the actual button. So basically, Pixelogic has arranged the tools you use the most right next to the canvas. And the cool thing here is that you can pretty much adjust everything you see here, and you can do that by going to the preference palette and open up the configuration subpalette and enable customize. And when you do that, you can see that the user interface slightly changes, and that's because you are entering the customization mode. And in this mode, you can now start moving interface icons around, and you do that by hitting or by pressing Ctrl-Alt on the keyboard, and then you simply drag and drop the icons around, right? And you can do that also by, I have my tool palette here. You can do that by storing or moving the palettes over to the trays, and then, for instance, in the tool palette here, you can start placing icons below the canvas. And when you are done with the adjustments, simply go to the preference palette again, disable customize, and store the configuration so your setup is still there when you start ZBrush the next time. So let me quickly undo this by enabling customization again, and I press Ctrl-Alt on the keyboard again, drag and drop the icons to the canvas to delete them. And as you now already know, they are not gone forever because we can still find them in the corresponding palette. So let me quickly move these guys back in place and exit the customization mode. So pretty much the same principles apply when you assign shortcut keys. To assign them, you do not have to enable customize. All you have to do is Ctrl-Alt-click on an icon or a button or a switch or a slider somewhere on the interface or inside a palette here to enable the assignment mode. So if I do this, for instance, on the solo button here, I hover over the solo button, Ctrl-Alt and click on the button. And then you can see at the top of the screen, you get this little message that you can now press any key combination to assign a custom hotkey. If I move the cursor away, the message disappears and the option or the operation gets cancelled. So let's do this one more time. Ctrl-Alt on the keyboard and click on the icon. And now you can assign pretty much any shortcut key to this button. So let me quickly choose one. Right, I've assigned the N key to it, and when you now click the N key or press the N key on your keyboard, you enable the solo mode here. And when you're done with assigning shortcut keys, don't forget to open up the preference palette again, go down to the hotkeys subpalette and store or save the hotkeys so they are still there when you launch ZBrush the next time. When you want to find out what shortcut keys are already assigned, you simply hover over a slider or a button like the draw size slider here, and you can see in the description that pops up the little S at the very end. That means that the S key is already assigned to the slider. So if you press S on your keyboard and have the cursor anywhere on the canvas or next to the canvas, the little slider pops up again and you can adjust the draw size of the brush on the fly. Let me quickly talk also about two other settings here that can be found in the preference palette. So if you open up the config subpalette, you have the restore custom user interface and the restore standard user interface. So if you do your adjustments here, let's say I open up the left tray, and I go to the preference tab and click on store configuration. The current configuration gets stored as my custom configuration. So if I switch back to the standard configuration, you can see that the left tray gets minimized again. And if I click on preferences, config and restore the customized user interface, so that's the one that we just saved a few seconds ago, you can see that the left tray opens again. In case you completely mess up the user interface, you have always the option to initialize ZBrush. So that gets rid of all of your adjustments and restores everything back to the default settings, right? So that's an option you have when you have gone too far with the adjustments. So that's about it for the user interface. This is all you need to know at the beginning. So let me quickly recap what we have just learned. We have our canvas in the middle here that is surrounded by some tools. All of these tools can be found in the corresponding palettes. The palettes are located in the drop-down menu at the very top. And then we have a left and a right tray that you can open up by double-clicking on these little arrow icons here. And you can dock the palettes by simply drag and drop this little circle icon over to the left or the right. You can adjust the user interface by going to the Preference tab, open up the Config subpalette and enable customization to enter the customization mode. And then you can move icons around by Control-Alt clicking on them and simply drag them around to reposition them on the user interface. You can get rid of the icons by drag and drop them directly to the canvas so they disappear, and you can find them again in the corresponding palette and drag them back in place. When you're done with your adjustments, go to the Preference palette again, disable customization mode and store your configuration, right? And the same of course works also for the shortcut keys. You simply hover over a button, then Control-Alt click on it, and you can now assign a custom hotkey. And when you do that, don't forget to save the hotkeys in the Preference palette again by clicking on Store or Save. Then there's one more thing I want to point out, and that's the size of the icons. So if the icons are a lot bigger on your side than they are in my setup, then that's basically because of the button size setup in the Preference palette. So if you go to the user interface subpalette and take a look at the button size here, you can adjust the little slider and move it to the left to make the icons smaller. And if you do so, you get prompted with this message where ZBrush tells you that the user interface will be adjusted the next time you start ZBrush. So make your adjustments here, then restart ZBrush, and the icons should have the same size as they have in my setup. And I usually also disable these white buttons here. And if you look to the left in the brush palette, you can see that the brush icons that are currently grayed out, they become a little bit smaller. So set the brush size to the lowest value and disable white buttons. Now let's take a look at the 2.5D concept and the 2.5D canvas. As you already know, ZBrush does not work with pixels but pixels instead. So we do not only apply color and position information, but also depth, orientation and material. And I want you to forget about 3D for a moment, where we actually place objects in a 3D scene or through a 3D viewport, and think of it more like a 2D program like Photoshop, for instance, right? The simple brush is already selected when you start ZBrush, and by choosing an alpha we define the shape of the brush tip, and by choosing a stroke we define the behavior of the brush. And of course we can also choose or change the color, choose a different color here like you would normally do when you set your brush in Photoshop. And because we are working on a 2.5D canvas, I can also change the material or choose a material. Let's go for the Hair 2 material, and then we can also change the depth information that we apply to the canvas. So it's currently set to C add, that means I'm adding a stroke to the canvas. And the C intensity defines the intensity of my stroke. So if I start now applying strokes to the canvas, you can see that the color information, material, depth, and orientation get applied to the canvas, right? Now, when you paint on the 2.5D canvas, you can immediately notice that it looks kind of 3D, but we cannot rotate the camera around the strokes or rotate the strokes in the viewport, right? And that's because the pixels are fixated to the 2.5D canvas. What I can do though is I can change the position of the highlights and the shadows, because orientation is also stored into the pixels. And you can do that by going to the light palette here and move this little point around, and you can immediately see that the direction of the light affects the shading of our brush strokes. I can now continue adding brush strokes or add brush strokes on top of already existing strokes. And if you switch from C-add to C-sub here, you basically push the pixels close to the canvas until they literally disappear behind the canvas. So let me quickly lower the C intensity just a tad and start painting, and you will see that the pixels disappear behind the canvas here, right? And we can also switch over to our eraser brush and start erasing pixels from the canvas. And if we disable C-sub and switch from material RGB over to color information only and pick a different color, we now apply only color information to the pixels. And the same, of course, also works with material. So if I switch over to material only and pick a different material, like the basic material here, I apply only material information. Let's try this reflected map just to give you an idea how this works. And we can, of course, also change the alpha to something else, like the star here, and the stroke type to a drag rectangle. And of course I have to enable C-add again and material RGB, and now we can draw little stars on top of our strokes. So this is basically how you add pixels to the 2.5D canvas in ZBrush. And now we can make this a little bit more interesting by clearing the canvas. So you can do that by going to the layer tab here and hit clear. Or let me quickly undo this by hitting Ctrl+C on your keyboard. You can also clear the canvas by hitting Ctrl+N. So that clears the canvas. And we move over to our tool palette and select 3D mesh. Let's start with this one here. And of course the same principles also apply to the 3D models. So I choose the hair 2 material again, adjust the color, and start drawing out these little stars on the canvas. And I want to point out that once you have drawn them on the canvas, you cannot manipulate them, because we are not drawing or building 3D models, we are just applying pixels, right? So this is pixel information that still reacts to the position of the light, because the orientation is stored into the pixels, but we cannot rotate these things around or look at them from a different angle, because they are fixated to the 2.5D canvas, right? But we can of course switch over to the simple brush again, choose a different color, deactivate C-sub, switch over to the RGB information and apply. Let me quickly change the alpha and the brush stroke, and apply color information to these 3D objects. Now let's quickly recap what we have just learned about the 2.5D concept. I clear the canvas by hitting Ctrl+N. You can find the 2.5D tools in the tool palette here. The simple brush is already selected when you launch ZBrush. You can control the brush with these settings here. We have material and color information only, material, C-add and C-sub. And we can control the intensity of the color and the intensity of the depth. So I'm activating C-add again and material RGB. I choose a material here and a color. So let's switch to the basic material and a color. And I can now start drawing pixels on the canvas. The stroke type defines the behavior of the brush, and the alpha pretty much defines the shape of the brush tip, like so. And because there is orientation stored into the pixels, we can change the direction of the light, and that affects the position of the shadows and the highlights. So you are now probably asking why I'm showing you all this. And to be honest, we will not expand the 2.5D tools, because we will work with polygon meshes in the next step. And still, we will continue working on the 2.5D canvas in ZBrush. And for this reason, it is crucial to understand how the principles work. And when you start using some advanced functions in ZBrush, it is very important that you understand the concept of pixels and the concept of the 2.5D canvas. Now let's clear the canvas again. And in the next step, I show you how to get from 2.5D to 3D. And I go to my tool palette over here again and pick a 3D mesh or 3D primitive, draw it on the canvas. And because we are still in draw mode, I can continue to draw instances of the mesh as pixels to the canvas like we did before. But this time I clear the canvas again by hitting Ctrl N. I draw the primitive to the canvas, and before I touch anything else, I enter the edit mode. So the edit button can be found at the top here, or you can just hit the T key on your keyboard. And this is very important. We are now entering the polygon level of the mesh here. And this is where the real fun begins in ZBrush. I will talk about navigation in a second, but for now, let's take a look at the polygons. And for this reason, I enable the polyframe. You can do this by hitting the button on the right here, or just Shift F on your keyboard. And if I zoom in close, you can see that our sphere consists of 4-sided polygons and some 3-sided polygons at the poles here. And if I zoom out and exit or hide the polyframe again and zoom out even more so that the polygons become small, the surface of the sphere appears to be smooth, right? And I can also hide parts of the sphere and go to the display properties here and enable double so we can see the rear side of our polygons. And now you can see that the sphere is hollow inside, but gets handled as a closed surface in ZBrush. Now you have also finally access to all of the brushes in ZBrush. They are accessible through the brush icon here, or you can also hit the B key on your keyboard to bring up the quick menu. And the standard brush is currently selected, and if I now try to apply brush strokes to the surface, I get prompted with this message that I'm still dealing with a 3D primitive and I have to turn it into a polymesh 3D before I can adjust the surface, right? So what does this mean? For every object you see here under 3D meshes, you have some unique initialize options. So if you go to the tool palette and down to the initialize sub palette, you can change the coverage of the sphere, for instance, and also the size. And let's say you are happy with the overall shapes. Then you have to turn it into a polymesh 3D to start sculpting, and you do that by clicking on this button, Make Polymesh 3D, and now you are finally able to apply brush strokes to the surface. So the standard brush is still selected, and I can now start manipulating the surface, right? So this works for every 3D mesh you see here, and let's switch over to another one, and I first exit the edit mode by hitting the T key, and ZBrush prompts me with this message that I'm about to leave the 3D mode and switch back to the 2.5D mode. So let's switch back and clear the canvas by hitting Ctrl N. Then I choose a different 3D primitive like the gear 3D, draw it on the screen or on the canvas, and before I touch anything else, I enter the edit mode again by hitting the T key. And now you can see that I have my initialize options available for the gear, and they look a little bit different than for the sphere because I have more options here to adjust the primitive, like the coverage or the outer profile, right? And again, when you are happy with the overall shapes, you can turn it into a polymesh 3D and start manipulating the surface. The standard brush is still selected, so I can start sculpting. Let's briefly recap what we have just learned. So to switch from 2.5D mode into 3D mode, all you have to do is go to the tool palette, pick a 3D mesh or 3D primitive, draw it on the canvas, and before you touch anything else, enter the edit mode by hitting the T key. And before you can apply brush strokes to the surface, do your adjustments in the initialize subpalette, and when you are done with the overall shape, turn it into a polymesh 3D by hitting make polymesh 3D, and now you are ready to apply brush strokes to the surface like so. And when we exit the edit mode by hitting the T key again, this little message pops up where ZBrush tells us that we are about to switch to the 2.5D mode. And when you do so, you draw instances of the 3D model as pixels to the screen again. Of course, this is pretty much useless, so I clear the canvas by hitting Ctrl-N on the keyboard, draw our model back to the canvas one more time, and before I do anything else, I hit the T key to enter the polygon level, and now I can continue sculpting. The next part will be quite intense, as I'm gonna show you a lot in a short amount of time. The things I'm gonna show you are not complicated at all, but it still requires you to pause the video from time to time to try the functions yourself. So only in case you have already installed ZBrush, of course. We will take a look at navigation together with a good deal of other basic functions in ZBrush that aren't rely heavily on shortcut keys. So shortcut keys are not hard to learn, but it simply takes some time and practice. I have linked the PDF file to the shortcut key cheat sheet in the description. If you go to 3dgladiator.com and subscribe to my newsletters, I will send you an email with a PDF file together with a whole lot of other links to everything that's currently available on 3D Gladiator for free. Before we continue sculpting, let's make some adjustments to the canvas, and you can find the canvas settings in the document palette, so I drag and drop it over here. And I always make sure that this auto fit window size button is checked before I click on new document, and what this does is basically it resizes the canvas to whatever screen size I have available here. So I click on new document, no, I don't want to save any changes, and the canvas gets resized, right? And in the next step, I usually also get rid of the gradient in the background. So I set the gradient slider to the far left. And I also change the color of the background, and you can do that by clicking on this color swatch here. And if you click and keep the left mouse button clicked, the cursor turns into a color picker, and you can now sample pretty much everything that's underneath the picker. So I go for a slightly lighter gray, like so. And when you are done with these adjustments, simply click on Save as Startup Document, and this tells ZBrush to come up with the same settings when you start the software the next time. So I save it as a startup document, and now I'm good to go. So let's get rid of the document palette by hitting or by clicking on this little circle icon, and we can continue sculpting. Now let's take a look on navigation, and therefore I pick, let's go for cylinder here, because you can see it a little bit better than just a sphere. I draw it on the canvas, I hit the T key to enter the polygon level or the edit mode, then I assign a different material to it, and in the initialize tab, let's make some quick adjustments and set an inner radius like so. And before I can start sculpting, I have to turn it into a polymesh again. And now I'm ready to apply brush strokes. The simple brush is selected, right? Okay, then let's take a quick look on the navigation. Navigation is pretty simple. You can rotate the model around by simply clicking somewhere next to the model on the canvas, right? And by moving the cursor around and keep the mouse button clicked, you rotate the model. You move the model around by pressing Alt on your keyboard, and then click somewhere next to the model on the canvas to move it around, and you zoom in and zoom out by hitting Alt, clicking next to the model, letting Alt go, and moving the cursor up and down. So that's a little bit complicated and requires you to try this a few times to get used to it, but I promise you it becomes second nature very fast. So once again, by just clicking somewhere on the canvas, you rotate the model. By keeping Alt pressed on the keyboard and clicking somewhere next to the model, you move it around. And by pressing Alt, clicking next to the model, letting Alt go and moving the cursor up and down, you zoom in and zoom out. And if you do that a couple of times, you should become pretty fast, right? And there's one more thing I want to show you here, and that's hitting the Shift key while rotating the model. So I'm clicking next to the model, I rotate it around, and when I hit the Shift key, it snaps in 90 degrees angles, right? So that makes it easier to position the model on the canvas. And you will see me using this Shift key while rotating pretty much all the time. And that's already about it for the navigation. You have these buttons on the right here, and they pretty much do the same that I have done now with the shortcut keys. So you can move the model around here by clicking on this move button. You can zoom in and zoom out, and of course also you can rotate the model. There's one more thing I want to point out, and this is when you come too close to the model. So I zoom in that it fills the entire canvas. I cannot rotate it around anymore because there is no empty space next to the model left. So if I would click here on the model, I'm already applying a brush stroke. And this is where this safe border around the canvas comes into play. So if you move the cursor over to or behind this white line, you are able to rotate or scale or manipulate or navigate without manipulating the actual surface, right? And let's say if you are that close, you can fit the model to the screen again by simply hitting the F key on your keyboard, right? The same works also if you zoomed out a lot and have it somewhere outside the visible area of the canvas, just hit the F key to bring it back or to center it to the canvas again. Now let's take a look at the cursor or the brush behavior, and I'm still in edit mode here, and you can see that the cursor is red, and if I exit the edit mode by hitting the T key, the cursor turns white, and that means I'm only into draw mode now and apply pixels to the canvas like so. So when I clear the canvas and bring back our model and hit the T key, I enter the edit mode and the cursor turns red, right? And let me now quickly switch over or choose a different primitive that has a little bit more polygons to work with, like the sphere 3D. So I draw it on the canvas, enter the edit mode, and as you now already know, before I can start sculpting, I have to turn it into a polymesh 3D. I do that by clicking on this button here, and I have my standard brush selected and see add enabled. I can now draw on the surface. Right, and you don't have to go to the top menu here all the time to switch between C add and C sub. So C sub pushes the polygons in and C add drags them out. You can do that, or you can switch between these two modes on the fly by hitting the Alt key. So if I have C add enabled and draw on the surface, I pull the polygons out, and when I press Alt and draw on the surface, I push them in, right? So Alt pretty much inverts whatever I have selected here. So if I have selected C sub and press the Alt key, I pull the surface out, right? And there's one more thing that I want to point out. And if you look at the cursor, you can see that it pretty much follows the curvature of the surface, and it does that by evaluating the face normals underneath the cursor. And this function was introduced a few years ago, and I usually go to the preference palette here and go down to edit and disable this align cursor to surface. So what this does is it makes the cursor a little bit more stable, so it's not wiggling around that much while I'm sculpting. And of course, the behavior of the cursor or the behavior of the brush remains the same, right? So it's just a little bit easier to look at. You can also adjust the radius or the size of the brush on the fly by hitting the S key on the keyboard. And this is possible because the S key is assigned to the slider. So if you hover over it, you can see the little S at the end of the description. So if I press the S key anywhere on the canvas, the little slider pops up and I can move it to the left or the right to adjust the radius of the brush on the fly. And this of course also affects the size of the brush stroke. So if I have set it really small, I only affect small portions of the model. And if I set it to something like this, I create large brush strokes and manipulate bigger portions of the 3D mesh. There is another important concept you need to understand when we talk about brushes, and this is how they are assigned to different key combinations or to the left mouse button. So if I hover over to the brush palette or the brush icon here and click on it, I get access to the quick menu. You can do that also by hitting the B key on your keyboard. And what you see here is pretty much every brush that's available in ZBrush. So for most of these brushes, I can simply assign them to the left mouse button by clicking on them, like the rake brush, for instance. And you can see that by the change of the icon here. So it changes to the symbol of the rake brush, and I simply apply it to the surface, right? And the same applies for a whole set of other brushes, like let's say the trim dynamic brush. I simply select it, the icon changes, it's now active, and I apply it to the surface, right? It's important to know that there is a set of brushes that cannot be assigned to the left mouse button. So the smooth brushes, for instance, then all of the mask brushes, the clip brushes, and also the trim brushes and the slice brushes, right? So for instance, the smooth brush is only accessible by hitting the shift key. Let me quickly switch back to our standard brush. And when I hit the shift key, the cursor turns blue, and that indicates that the smooth brush is now active. So I can now smooth out the surface, right? And I can also pick different smooth brushes by opening up the quick menu here and choose, let's say, the smooth valleys. And now I can smooth out the valleys between peaks by hitting the shift key. Then we have a set of brushes assigned to the control key. So if you hit control, the cursor turns yellow, and that means that all of these mask brushes are now accessible. Mask pen is selected by default, and it allows me to draw a mask directly on the mesh. I will talk about masking later on in great detail, but for now it's important that you understand that different brushes are assigned to different key combinations. And of course it gets also even more complicated. We have access to another set of brushes by hitting the control and the shift key. And here the select rectangle brush is already selected by default, and we have also access to the clip brushes, to the slice brushes and the trim brushes, right? And you're probably asking why this is so complicated, and there's a very good reason for it. And this is that with some practice, it allows me to focus entirely on the sculpting process instead of going back and forth to the brush palette all the time to pick different brushes. So let's say I'm working with a standard brush here, right? And then I hit Shift on the keyboard to smooth out certain areas. Then I hit Control Shift together to isolate certain parts so I can focus only on them. Then I can mask parts by hitting the control key and draw a mask, so parts that are masked do not get affected by the brush, right? Then I can show the entire model again. I can clear the mask and I can continue smoothing things out or adding additional brush strokes. And I do all of this without having to go back to the brush menu and pick different brushes, right? So that's a little bit complex and complicated at the beginning, but it becomes second nature pretty fast, and you don't want to miss the quick access to a different set of brushes, right? So we can now basically take it one step further from here and apply colors to the polygons. So like we did already when we were applying 2.5D brush strokes to the canvas. And you simply do that by having any brush selected. I have my standard brush here, and I go to the top menu, disable C-Add, enable RGB, select a different color. And when I do that, you can see that the selected color gets applied to the entire model. So we set it back to white again and open up the color palette at the very top and fill the object with the currently selected color. And now I change a different color and apply it directly to the surface. So it works pretty much the same way like it did when we had the strokes in a 2.5D canvas, right? And of course you can apply different colors to the model, and you basically paint directly on the polygons. That means the denser the mesh is, the more polygons you have available to paint on, and the more details you can add to the model. So if I want to clear everything here, I can set the color back to white, open up the color palette again, and select fill object, right? And the same, of course, also works with materials, but in this case we have to select the material channel here and open up the color palette again, click on fill object, and now with only the material channel selected, I pick a different material. Let's go for the reflected matte material, and when I now paint, I only apply material information to the polygons. So again, the concept is the same as we already had it with our 2.5D pixels on the canvas, right? Next, let's talk about the mask function in ZBrush. And for this reason, I go to the tool palette again and pick a sphere 3D, draw it on the canvas, enter the edit mode, turn it into a polymesh 3D, and add a couple of subdivision levels. So you can do that in the geometry tab here by clicking on divide a few times. And that basically gives me more polygons to sculpt with and also to draw my mask on. I will talk about the geometry subpalette and different workflows later in this video, but for the moment I only need a model with a higher resolution, so I get rid of the lower subdivision levels here. And as you now already know, the mask brushes can be accessed by hitting the control key. So if I hit the control key, I have here my mask tools, and the mask pen is usually already selected by default. And if you now draw on the model by hitting the control key, you are applying a mask, right? So the cursor turns into a yellow cursor with a little plus sign in front of the word mask. And if you hit the control key together with the alt key, the little plus turns into a minus, and that allows us to delete parts of the mask. So I can mask certain areas and I can unmask certain areas by hitting Control and Alt together, right? And these masked areas, they do not get affected by the brush. So if I start applying the rake brush to the surface, everything that is masked remains untouched by the brush. And we can simply invert the mask by pressing the control key and tapping somewhere next to the model on the canvas, right? I'm clicking here, and this inverts the mask, and now everything that was previously masked is unmasked, and I can continue applying brush strokes here. You delete the mask by again moving the cursor next to the model, pressing the control key, and then left clicking and drawing this little rectangle, right? And that unmasks everything. And you can use the rectangle, of course, also to mask. So if you move the cursor away from the model, press the control key again, draw this rectangle, and then simultaneously also press spacebar. You can move the rectangle over on top of the model and apply the mask to everything that's visible at the moment. So not only the polygons that are facing us, but also the polygons at the back of the model, right? And again, let's clear the mask by hitting the control key again, and drawing this little rectangle outside the model. And you have different shapes of masks available. So if you press Control key again and go over to the brush palette, we can, for instance, select the circle, and it works the same way as the rectangle. So I draw a circle somewhere outside the model, move it over to the model, let it go, and then it masks certain parts of my model in a circular area. So you can also do that by having the cursor directly over the model and hitting the Control key and then draw the little circle here, right? Then there's another cool tool that I use a lot. That's the mask curve tool. And let me quickly clear the current mask by hitting Control and drawing somewhere outside the model. And the mask curve tool allows to draw a curve here. And I do that by hitting the Control key again, start drawing the curve, let Control go and hit the Alt key or tap the Alt key. And whenever I do that, I can create these curve points and apply a mask. And this option allows me to paint or place pretty complex shapes of masks on the model, right? And again, you can switch to a different tool by hitting the Control key. Let's switch back to the mask pen again. And when you drag the rectangle next to the model, the mask gets cleared or deleted. So now that you know how to mask your models with shortcut keys and the mask brush, I would like to show you other options for masking, and they can be found in the tool palette. If you go down to the masking sub palette, you have several options here for masking. So let me quickly draw a mask back on our model again. And you have here the option to view the mask or hide the mask. You can do that also by clicking Control H to hide the mask. So even if it is not visible anymore, it still works, of course, right? So if we click on View Mask, we can see our mask again. Then of course you can inverse the mask, you can clear it. Let's undo this and inverse it again. And a very cool feature here is also that you can sharpen the mask. So if you click the sharpen button a couple of times, you sharpen the mask, and it works also the other way around by blurring the mask. So if you hit the blur button a few times, the edges of the mask become blurry. That can be also done on the fly directly on the model. So if I clear the mask and mask this area here, and if I now Control click on the mask, I basically blur it. And if I Control Alt click on the mask, I'm sharpening it, right? So Control click on the mask for blur and Control Alt click on the mask for sharpening it. And then I sometimes also use grow mask and shrink mask in combination with sharpen. So if I grow the mask and click on sharpen a couple of times, it becomes a little bit bigger. And if I shrink the mask and sharpen it again, it becomes smaller, right? And beside that, you have several other options for masking. These are pretty advanced features already. So for instance, I can mask by cavity. So the mask only applies in these little valleys here. Or also, let's say, by smoothness, right? So if I mask by smoothness, all the areas that are pretty smooth remain unmasked. And I can, of course, invert the mask, and everything that sticks out of the model or has a rough surface gets affected. Then let's take a quick look on how to select certain parts of the mesh or isolate them. So as you already know, the select tool can be accessed by hitting Control together with the Shift key. And then we have here our tools that are assigned to this key combination. The select rectangle is already selected by default. And if you press Control Shift together and start drawing a rectangle next to the model, this green box appears, and whatever is underneath the green box gets isolated. So I'm basically hiding the rest, and everything that was under the green box, also the faces at the back of the model, are now isolated. I can bring back the complete model again by hitting Control Shift together and tapping somewhere on an empty area of the canvas, right? So let me quickly undo this to show you how I invert the selection. And you simply do that by pressing Control Shift on the canvas and not tapping on the canvas, but drawing a rectangle again. So this inverts the selection, right? So let's bring back everything by Control Shift clicking on the canvas, and then repeat the process by Control Shift clicking again. I draw the rectangle, then I let Control Shift go and press the Alt key to turn the select rectangle box into a red box. And if I now move the box around, or I move it around first by pressing the space bar, and if I now hold down the Alt key, I pretty much hide everything that was under the red rectangle, right? And like for the other tools, we also have here some different modes available. So if I go into the select rectangle, or if I go into the brush palette here, I can, for instance, select your lasso selection tool and do the same here by using the lasso to do my selections, right? So I can do this a little bit more artistically than just drawing a rectangle, right? If you now isolate or hide certain parts of the mesh, you can do that by hitting the Alt key and go to the tool palette again and down to the visibility sub palette. You can grow the selection, and that brings back some of the isolated polygons again, or of course you can also shrink the selection and hide more of the currently visible polygons, right? And you bring back everything again by simply hitting Control Shift and then tapping or clicking somewhere on an empty area on the canvas. I'm not going to cover any of these advanced brushes here, like the clip brush or the slice or trim brush at the moment, but I would like to introduce you to polygroups, because polygroups are very handy and they usually come in combination with the mask tool and also the select tool, right? So the polygroup sub palette is available in the tool palette here, polygroups. And if I enable the polyframe by hitting Shift F on the keyboard or clicking this button over here, I do not only see the wireframe of our mesh, so the single polygons, I can also see that a color is applied to the entire mesh. And that's basically already a polygroup that's assigned to everything that's currently visible, right? So if I go over to the polygroup subpalette and click on group visible, a new polygroup gets assigned to the mesh. I can keep clicking, and every time I click, a new polygroup is assigned, right? So when I now isolate certain parts of the model by hitting Control Shift key again and isolate a part, right? And click on group visible again. Let's click it a couple of times to assign a nice color, and exit the isolation mode by hitting Control Shift together and clicking next to the model. You can now see that I have two polygroups assigned to the mesh. And the cool thing here is now, let's say you would like to keep working on this part or to isolate this part and work on some details. You do not have to use the rectangle to isolate it. You can simply Control Shift click on the polygroup, and that hides the rest of the mesh, and only the parts that share the same polygroup remain visible, right? Of course, this works also when I click on the other polygroup. So simply Control Shift click on it and you isolate the selected part and the rest gets hidden, right? And the same works if I apply a mask. So let me quickly disable the polyframe here, and I draw a mask by hitting the Control key. And when I now hover over the mask and hit Control W on the keyboard, the mask seems to disappear actually it disappears. But if I enter the polyframe mode again by hitting Shift F, you can see, you can barely see that the mask gets replaced by a new polygroup. So if I Control Shift click on it, I can isolate it. I can assign a different polygroup to it so we can see it a little bit better. Right? I can now isolate these individual parts and work on them separately. So this becomes handy when you are dealing with a mesh that consists of millions and millions of polygons. And in this case, it's sometimes necessary to hide certain parts or to hide large parts of the model to speed up the workflow and to focus on areas you are currently working on, right? Before we take a look at the different workflows in ZBrush, I would like to show you a few more tools, and an important one is the transpose tool. So I go over to my tool palette, pick a primitive 3D, let's go for the cube, draw it to the canvas, enter the edit mode. I show the polyframe by hitting Shift F on the keyboard, and then let's turn it into a polymesh 3D. And to change the assigned polygroup color, we open up the polygroup subpalette and I click on group visible a couple of times. And then I also enable or show the floor grid, and you can do this by clicking on the floor grid button over here, or by hitting the Shift P key on your keyboard, right? To activate the transpose tools, you have several options, and at the top here, next to the draw mode, you can see we have move, scale and rotate, and there are already shortcut keys assigned to them: W for move, E for scale and R for rotate. And when I now press the W key on the keyboard, this little gizmo appears in the middle of the object or in the center of the object. And this guy is pretty self-explanatory because you have these elements of the gizmo that allow you to move the object around by clicking on the arrow here. So I move it along the axis, right? And I can also scale and rotate it, even if I'm only in the move mode here. So you can scale it, uniformly scale it by clicking on the yellow box in the middle to scale it up and down. You can non-uniformly scale it by clicking on these boxes that are placed along the axis, right? And of course you can also rotate it by clicking on the circles here. And you can move it freely around in space by clicking on these gray arrows around the gizmo. With the transpose tool, you can do, of course, a lot more than just rotating, scaling and moving the model around. But at the moment, it's only important that you know how to access the gizmo and how to do basic operations, because we will need them in the next step when we take a look at the subtools. So before we do that, it probably makes sense to explain what a tool is. So basically every 3D object in ZBrush gets handled as a tool, right? So for this reason also the tool palette is maybe one of the most important palettes in ZBrush, and it also contains a lot of functions that can be applied to a 3D model. And in this context, it also makes sense now to explain you how to save your projects or how to save your 3D models in ZBrush. And basically you have three options here. And option number one is to save the 3D model as a tool, right? And you can do that directly in the tool palette here. At the very top, you have the options to load a tool or save the tool. So if you click on, if you have your 3D model in edit mode here, you can save it as a CTL file, as a ZBrush tool, right? And when you start ZBrush the next time, you simply open up the tool palette again and click on load tool to load the ZBrush tool. And then you can draw it to the canvas, enter the edit mode and continue sculpting, right? And this was basically the only option to save 3D models for a very long time, until Pixologic has introduced the option to save the entire project. And this can be done by going to the file palette here and save the entire scene as a project. And what this does is it basically saves everything you have loaded here into the tool palette together with your brush settings and the canvas settings, right? And in this case, the file size is a lot larger than saving it only as a tool, but it gives you the possibility to continue sculpting where you have left off the scene last time, right? And then there's a third option, and this is the one you probably never going to use because it only saves the document with the 2.5D pixel information. And that works like this. So if I exit the edit mode here and draw a few instances of our 3D model as pixels to the canvas, you can go to the document palette and save only the 2.5D document. So only the document with the pixel information on it. Unless you do some crazy 2.5D illustrations, you will not use this option because you are always going to save the 3D model as a tool or the entire project with all the tools by going to File and save the entire project here, right? So now a tool can not consist only of one object, but we can have several objects stored into a tool. And let me quickly demonstrate how this works. So I pick the cube primitive, draw it on the canvas. Let's assign a different material like the skin material here to make it a little bit brighter. And I also assign a different color to it. But before that, I have to turn it into a polymesh 3D. Then I select this bright red here, go to color and fill the object. And if I now open up the tool palette, you can see that I have one layer with my cube object on it. And there exists a few options to create more layers with different subtools. And the first option I would like to show you is the duplicate option. So if you click on duplicate, the currently selected layer gets copied, and I have now two layers with two cubes on it. So if I select layer number 2 and activate the transpose tool, I can move it over to the side and also assign a different color to it, like so. So we can distinguish them a little bit easier. Now we have two layers with two tools in it. Then of course there also exists a second method to append tools as subtools, and that can be done by clicking on the append button here. And you can now basically append every tool that's currently loaded into the tool palette. So let's go for the cone 3D. It gets appended as on a third layer here, and it's currently not visible because it's probably hidden underneath the box. So I enter the transpose tool and move the cone aside and assign a different color to it again, like so. All right, then we have three different layers with three subtools on it, and you can cycle through them by simply using the arrow keys on your keyboard. So let me quickly enable the polyframe. That allows us to see this a little bit easier. And when I now hit the arrow keys, the up and down keys, I'm cycling through the tools. And you can do this also directly in the viewport and on the fly by holding down the Alt key and clicking on the model to activate it on the corresponding layer, right? And you can also organize these layers. So I'm on the first layer here by hitting the Control key and the arrow key, and that moves the layer up and down in the stack. The subtool panel contains many other functions, and I would like to quickly show you how to use merge and split. So let's start with merge. I have the first layer in the subtool list selected, and if I click on merge down, the first layer gets merged with the second layer. So let's click on it, and you get prompted with this message where ZBrush tells you that this is an undoable operation, but I'm fine with that, and click on OK. And then we have both cubes on the same layer again here, right? And if we do this one more time, I can merge them down into a single layer. So I merge the two cubes with the cone. And now let's assign a white color to all three of them by going to color fill object. And if I go down to the polygroups sub palette here and enable the polyframe and click on group visible, ZBrush assigns one single polygroup to all 3 objects. And if I click on auto group, each object gets its own polygroup, and that helps us when we perform a split operation. So I go back to the subtool panel and open up the split subpalette, and when I now click on group split, every object with a unique polygroup gets placed on a separate layer, right? So I have my cube here on a layer, I have the cone on a layer, and the second cube on a layer too. And of course you can merge everything down into one layer again by opening up the merge palette or merge subpalette here and click on merge visible. And this does nothing on our list here, but ZBrush appends a new tool that contains all of the objects on one layer. So before we finally become a little bit more practical in ZBrush, I would like to demonstrate one last function, and that's symmetry. So let me quickly draw a primitive on the canvas again and turn it into a polymesh 3D. And under the geometry subpalette, I divide it a couple of times, delete the lower subdivisions, make sure that my standard brush is selected. And if you go to the transform palette, you can activate symmetry here or simply hit the X key on the keyboard. And this basically allows me to work on 2 or more sides of my model simultaneously. And this is something that made ZBrush famous at the very beginning, because it felt so intuitive to work on 2 sides of your model simultaneously, and gives you a lot more control about the outcome, right? So let me quickly undo this. And we can of course also activate more axes like the Y and the Z axis all together, and that allows us to create very complex shapes in no time. Right, and there's also another cool function here, and that's radial symmetry. And let's quickly disable the Z and the Y axis and set the radial count to something like 12. And now you can see that I have 12 brushes or 12 instances of my brush enabled at the same time. And I can now create really complex models in no time, like so. And when you are done, you can simply exit the symmetry mode again by hitting the X key on the keyboard. And then you can continue sculpting with a single brush. The great thing in ZBrush is that it's really all about sculpting. It's about building shapes and volumes and adding details without worrying about the technical stuff that needs to be considered later on in the pipeline. So this means you can focus on sculpting first and then still concentrate on technical parts when you are done with modeling. Furthermore, you are already good to go with only a small set of tools. So focusing on the creative part first, together with working with only a few tools, was a real game changer when ZBrush was introduced to the market, because this approach didn't exist before. At the present time, there are only 2 ways to start sculpting in ZBrush. You can either create the mesh in ZBrush itself by starting with a 3D primitive or a ZSphere, or, and that's the second method, You can import a mesh from an external application in a file format that is supported by ZBrush. That would be an FBX file, an OBJ file, or an STL file. The workflows I'm gonna show you in the next part apply to both meshes, so the ones that are created in ZBrush itself and also the meshes that you import from an external application. Before I continue, you also need to understand that there not only exists one workflow to create a 3D model. 3D modeling is always a combination of different workflows. So basically, how you start really depends on the project requirements and your personal preferences. And still, the goal of each method is to come up with a more or less detailed and clean mesh. Regardless of the method, keep in mind that you are dealing with polygons in ZBrush and that each workflow interlocks at a certain point. So this means a simple piece of geometry can be turned into a dense mesh, and a dense mesh can be turned into a simplified piece of geometry again. This also means that you are not tied to a certain workflow from start to finish, and it's up to you to decide which procedure works best. Showing you different workflows is what part 4 of this tutorial is all about. In the following demonstration, I want you to focus mainly on what happens with the mesh and not so much on the tools I use. By doing so, you will see that the approach is a little bit different each time, but the subject matter pretty much remains the same. We can of course discuss functions like Dynamesh or sculptors in great detail in a later video, but for now it is very important that you understand the core principles. Without this knowledge, you cannot decide which tools to use when. So let's start with the most basic procedure first, and this is simply by subdividing the geometry. So how to work with subdivision levels is pretty easy to explain. I go to my tool palette again, pick a 3D primitive, place it on the canvas, turn it into a polymesh 3D, and then I go down to the initialize tab, and this goes for all of the primitives or any mesh that you have turned into a polymesh 3D. The initialized settings are now the same, so based on these resolution settings you can turn it into a cube, a sphere or a simple grid, and I continue with the sphere here because it consists only of a few polygons and it's perfect for demonstration. And then I go up to the geometry subpalette, I'm still in the tool palette here, and start subdividing the mesh by hitting the divide button, and you will immediately see that the surface looks a little bit more detailed now, and that's because I have subdivided each polygon by 2, right? And if I continue subdivide, the surface becomes smoother and smoother. And there's of course also a shortcut key again to subdivide the model on the fly, and that's Ctrl D. So if you hit Ctrl D, you add another subdivision level. And then I want to point out also these active points at the top here. And they basically tell how many points or how many vertices you have available to sculpt with. At the moment we have 24,000. So if I hit Ctrl D one more time, or let's say one more time, then we almost reach 400,000 points, and the surface is now quite smooth and has enough resolution to apply pretty fine details, right? And the cool thing here is that we do not only apply subdivision levels, but they remain available in the geometry tab here. So I can basically move this slider over to the left to go back down to the lowest subdivision level. This is the level where we have started adding subdivisions, right? And you can step up or step down through the subdivision levels by hitting the D key on the keyboard. To go one level up, or you can click Shift D to move a level down, right? And you can do that on the fly here until you reach the lowest subdivision level again. So you are now probably asking what this is all good for. And one of the main advantages here is that you can use subdivision levels to make large changes on the lowest subdivision level, for instance. So if I switch over from the standard brush that is currently selected to the move brush, right, and go down to the lowest or the second lowest subdivision level and make my adjustments here, I can manipulate the surface or move large chunks of polygons around, and then I can step up the subdivision levels, select the rake brush, and add smaller details on the highest subdivision level. And if I now go down again to the lowest level or to the second lowest level, switch over to the move brush and make large adjustments on the surface like so, the details, they remain unaffected if I step up again to the highest subdivision level. So our details are still there, right? The thing is that we are running in a bit of an issue here when we make large adjustments on the mesh. So let me quickly step down to the lowest subdivision level or the second lowest subdivision level, and with the move brush I'm going to make these heavy changes here, and when I show the polyframe again, you can see that the polygons are quite distorted, or they are now a lot larger than they are on this side here. And if I switch back to the highest subdivision level again and start adding fine details here, you can see that we already deal with some distortions here. And that's because we made these large adjustments on the mesh on this low resolution level, right? And working with subdivision levels requires you to do some initial planning before you start modeling, because the base mesh or the shape of the base mesh, it has to remain pretty consistent, right? So you cannot do these large adjustments without running into these distortions here. That means that when you are working on a character, you have to build the base mesh or the low resolution mesh in ZBrush or in another application, and then bring it to ZBrush and start subdividing it there and work on the details without touching the main shapes or the big shapes too much, right? So let me demonstrate subdivision modeling on a more practical example, and I've loaded a concept sculpture I made a few years ago. It consists of several different subtools. So I select the head and enable the solo mode to hide everything else. And if we open up the geometry palette or the geometry sub palette here, you can see that subdivision levels are still available. And if I slowly step down through the subdivision levels by hitting Shift D, I end up on subdivision level 1, and you can see that it's basically nothing more than a simple box or a sphere-like shape that consists only of a few polygons. And I actually started from here. This method has the great advantage that you have to focus on primary shapes with this low amount of polygons, right? And when I was happy with the overall shape here, I was adding the second subdivision level, and then I was continuing adding details, a little bit smaller details, and defining the shapes even more, until I ended up on subdivision level number 6, which is still low in this case, but this was only planned as a concept sculpture. And on subdivision level 6, I was able to add finer details like the beard here, for instance, or single hair strands, right? And again, this method is absolutely fantastic for not getting distracted by the amount of polygons or points. So for instance, if you imagine that you subdivide a sphere a couple of times, you then have already so many polygons available to work with that it can be hard to focus on primary, secondary, and tertiary shapes. And if your primary shapes aren't solid, also the secondary and tertiary shapes, or let's say fine surface details, are not able to turn it in a great sculpture, right? I want to point out that nowadays I would probably start a little bit different, because a few years ago Dynamesh or Sculptris was not available, so starting with a simple base mesh and subdividing it step by step was pretty much the only method to reach or to create a high resolution model. And I was already running into some issues here, like in these areas, for instance. So the distortions become obvious even if I would subdivide the mesh even further, because I made quite large adjustments on the base mesh here. And today I would start with a Dynamesh and lay out the basic shapes there until I'm happy with them, and then I am converting it into a subdivision model. But I will show you how this works later on, right? So that's a practical example on subdivision modeling. I also want you to keep in mind that subdivision levels are not only used for modeling, they are widely used in all kind of production pipelines. So for instance, for rigging and animation, you would do that on a low resolution mesh and then add some sort of smooth modifier to the mesh while rendering. And for game characters, for instance, you start with a basic base mesh, then apply your subdivision levels to it, add all the details, go back to the lowest resolution level again, turn this mesh into a mesh that can be used in the game engine, and use the low res mesh together with the high res mesh to bake all kind of maps or create textures, right? So it's not something that's only used in modeling. So subdivision levels also work the other way around. So imagine that this is a mesh that consists of only 4-sided polygons. And let's also imagine that we do not have any subdivision levels intact. I go to the highest subdivision levels, so this would be level 6 in this case, and delete all lower subdivisions, right? So we do not have the possibility now to step through the single subdivisions. And in this case, and this works only if the mesh consists of 4-sided polygons, we can let ZBrush reconstruct the subdivision. So if you go to the geometry subpalette here and click on reconstruct subdivision, ZBrush reconstructs the levels step by step until it reaches a point where it's not able to simplify the polygons again, right? And that's a great way to turn a high resolution mesh that consists of 4-sided polygons into a low res mesh with subdivision levels. Unfortunately, this does not work when the mesh consists of triangles, and I can show you this by loading up a 3D scan. And if we zoom in close and activate the polyframe by hitting Shift F, you can see that this model consists of triangles, right? And if I go back to the geometry tab and click on reconstruct subdivision, ZBrush prompts me with a message at the top that the operation is cancelled because the mesh contains triangles, right? But there is a solution to this, and we can still turn the high-res mesh into a low poly model or a low poly base mesh. And the first thing I do here is I go to the subtool palette and duplicate the current tool, so we have a copy here. And as I'm already in solo mode, only the selected layer is visible. Then I go down into the geometry tab and open up the ZRemesher. And ZRemesher basically reconstructs the high resolution mesh according our settings. So the current target polygon count is set to 5. I can lower it to something like 2. Maybe 2 is already too low. Let's try 2.5. And I also activate the legacy mode 2018. So this is the algorithm that was available in previous versions of ZBrush, and it works a little bit better on smooth surfaces. And then I simply click on ZRemesher and let ZBrush do its calculations. So this will probably take a minute or so, and I'm going to pause the video and we'll be back with the final result. So see you in a second. So this is what we end up with here, and I think ZRemesher did a great job. We can compare both versions by opening up the subtool palette, and I switch between the layers by hitting the arrow keys on the keyboard, and you can see our original model has a pretty dense mesh, and our low-res model now consists of quads or four-sided polygons. And when you take a look at the point count, the new mesh consists of around 7,600 points, whereas the original has almost 400,000 points, right? We are running into two problems here. So the first one is that we have lost all of our details. If I open up the subtool palette and switch between the original and the new base mesh, you can see that the main shapes are here, but we have lost all of our details, right? And the second issue is that we do not have any subdivision levels yet. And that's what I'm going to change in the next step by hitting the divide button once. And then I switch back to the subtool palette, exit the solo mode. So you can see that both meshes are overlaying each other. We have the original here and our reduced version beneath. And what I do next is I make sure that both layers are visible and that I'm on the layer of our base mesh, and then I go down into the subtool subpalette to the project tab and click on project all, right? Give it a second to calculate. And what this does is it basically transfers all of the details from the high-res mesh to the low-res mesh, or let's say as many details as possible, because we are still on a quite low resolution level for our new mesh here, right? And then I simply repeat the step. I open up the geometry tab again, click on divide one more time, switch back to the subtool palette and click on project all again. Give it a few seconds to do its calculations, and then it should already bring back even more details from the original. And keep in mind that this only works if both meshes are overlaying each other perfectly, right? And let's do this one more time by hitting Ctrl D to add another subdivision level, and then I click on project all. Give it a few seconds again to transfer the details from the high-res mesh to the low-res mesh. It depends on the processing power of your workstation, right? And here we are with a pretty perfect representation of the original mesh. So if I switch between these two, you can barely see any difference. Actually, our new mesh is still pretty low res. So we could basically add another subdivision, and then we are already into the millions of polygons, and repeat the project all process one more time. By doing so, we eventually end up with a subdivision surface. So that means I can go to the geometry tab here, switch down to the lowest subdivision and start making my adjustments here. So for instance, I can activate the transform tool, and I disable the gizmo here. So the transpose line appears, and I can now use the topology to mask the model and make large adjustments like so, for instance. So I place the transpose line in the middle here and bend the mesh over. Then I'm going to fix these areas a little bit to make them fit. And when I'm done on this level, I step up one subdivision level, switch over to the standard brush, lower the intensity down to something like 15, and continue cleaning the shapes here, right? Let's switch over to the move brush one more time, lower also the intensity of the move brush, and adjust the surface. Of course, this is also possible without going through the process of rebuilding subdivision levels. But then it's a lot harder to do. So if I switch back to our original 3D scan and activate the transpose line again, I already have a hard time masking the thing, right? So I would have to draw a mask like so, and then maybe blur it and switch back to the transpose line again, and let's try to rotate the whole thing. And you can see, because of these triangles here, the mesh already gets distorted, and these areas are sometimes very difficult to fix, right? So having subdivision levels gives you great control on the shapes and on the details, and it makes it easy to work on large shapes on a low resolution level, and it's quite easy to add details on a high resolution level. And you can then later on use the base mesh for map baking, or you can export it and use it for rigging and animation, and then apply details through maps and textures during rendering, right? This is all you need to know about subdivision modeling or subdivision levels. And give me 2 minutes again to briefly recap what we have just learned. So basically you can apply subdivision levels, or you can subdivide every mesh in ZBrush as long as it is a poly mesh. So if I choose a primitive 3D here, draw it on the canvas, turn it into a poly mesh, go down to the initialize settings and turn it into a sphere for demonstration. So we can start with a very low res model here. Then I go to the geometry sub palette. I'm always in the tool palette, and start subdividing it by hitting the divide button or Ctrl D on your keyboard. You are basically dividing each polygon by 4. If you take a look at the active points, you can see that the number gets multiplied by 4 each time I press Ctrl D on the keyboard, right? And then I have my subdivision levels here still accessible, so I can step through them by hitting Shift D to go down one subdivision level after the other, and the D key to step up a subdivision level. I do large adjustments on the lowest level or on a low level by, for instance, adjusting the mesh with the move brush, and then I can continue adding smaller details on a higher subdivision level. And let's quickly pick the rake brush here and add some details. And we must be a little bit careful, because when we use this method, the base mesh has to be already quite defined before we start applying or before we subdivide the mesh, because we cannot do super large adjustments on the base mesh, because that leads to distortions, right? So if I do something like this and then try to apply small details with the rake brush again, you can see that I do not have that many polygons available in this area as I have it here, for instance. And that's simply because we have stretched the polygons out too far, and then we have to deal with these distortions here, right? Except that it's an absolutely fantastic method for sculpting. You can focus on the primary shapes on a lower resolution level, and then on secondary and tertiary shapes on a higher subdivision level, right? And you can also use the low res mesh for map baking or to export for rigging and animation, and then reapply details from the high-res version as maps or textures, like displacement maps or normal maps later on in the game or during rendering. Alright, then let me show you another method to create meshes in ZBrush. So I go to my tool palette again and pick a primitive 3D. We go with the sphere 3D, and I enter the edit mode and turn it into a polymesh 3D. And when I show the polyframe by hitting Shift F on the keyboard, you can see that the topology is nice and clean. The sphere
mainly consists of four-sided polygons, and if I zoom in close to the poles here, you can see that we have some triangles that build the poles, right? So if you hit F on the keyboard, you can frame the mesh and center it to the canvas. And I'm hiding the polyframe, go to the tool palette and to the geometry subpalette, and we do not touch any of these settings now. I go straight down to Dynamesh. And Dynamesh basically is short for dynamic mesh. And if I hit the Dynamesh button with these settings here, it looks like nothing has changed until I show the polyframe again. And now you can see that ZBrush or Dynamesh has rebuilt the surface. Our poles are gone, and now the surface consists mainly of four-sided and a lot of three-sided polygons, right? So far so good. So if I switch over to the tool palette and pick move elastic brush this time, for instance, and also enable symmetry by hitting the X key on the keyboard, I can start making these large changes like so. And if I show the polyframe again, you can immediately see that we are running into the same issues like we already had before. We have these distorted polygons in these areas because there is simply not enough information or resolution available to make these large adjustments, right? But because we are still in Dynamesh mode, we can tell ZBrush to rebuild the surface, right? And you simply do that by hitting the Control key and drawing this little mask rectangle somewhere next to the model, and the surface gets immediately rebuilt, right? And we now have enough resolution or enough polygons in the previously distorted areas to continue sculpting, right? So let's quickly repeat this process and draw out these spikes or these horns at the bottom of the sphere and show the polyframe again. And we have heavily distorted polygons in these areas like we had before. And now I'm running Dynamesh command again by hitting the Control key and drawing this little mask rectangle somewhere next to the model. And as soon as I do that, Dynamesh recalculates the topology, and I have now enough polygons available again to continue sculpting, right? So this allows us to build pretty much every shape or form you have in mind, right? And you can control the amount of polygons here. So always take a look at the active points here. We have around 115,000 at the moment. You do control the resolution by setting the resolution slider over here. So it's currently set to 128, and let's higher it a little bit, or let's increase it a little bit to 300, for instance, and run the Dynamesh command again by hitting the Control key and drawing the little rectangle next to the model. And it takes 2 seconds to rebuild the surface. And now you can see that we have a lot more polygons available to sculpt with, right? And let me quickly switch over to another brush, like the claybuild-up brush, for instance, and add some small details here, like so. And there is an important thing I want you to keep in mind, and this is that we do not have subdivision levels available like we had before when we were dealing with subdivision surfaces. So this means that the resolution only gets controlled through this slider here. So if I set it back to something low like 40, right, and tell Dynamesh to rebuild the mesh, I'm losing all of the details that I have just added on a higher resolution level. So I'm not able to step through the subdivision levels here because they do not exist. So if you take a look at the geometry, at the top of the geometry subpalette here, we do not have any subdivision levels available, right? And that's something to keep in mind when using Dynamesh. So you would usually start with a low resolution and define the primary shapes of your model, like so. And every time you run into areas that needs more polygons, you simply let Dynamesh rebuild the surface, right? And let's say you reach a point where you are happy with how the model looks, right? You can then start to slowly increase the resolution, like so, rebuild the surface, and slowly begin to add smaller details, like so, right? I would like to expand on the Dynamesh concept a little bit more, because there are a few things that you need to know when working with Dynameshes. So I go to my tool palette again, pick the sphere, draw it to the canvas, turn it into a polymesh 3D, open up the geometry subpalette, go down to the Dynamesh tab, and let's lower the resolution down to something like 80 for instance, and click on Dynamesh, right? And the first thing I want to point out here is Dynamesh always works with closed surfaces. So you cannot have an open surface and turn it into a Dynamesh. Of course, this works, but Dynamesh will close any holes automatically for you. So I can demonstrate that by isolating part of the mesh. So I hit Ctrl-Shift on the keyboard and switch back to my select rectangle and isolate this part of the mesh by hitting Ctrl-Shift first, drawing the rectangle, then let Ctrl-Shift go, hitting the Alt key to isolate the part that was underneath the red rectangle, right? And of course, it is still there, it's just hidden. And to delete this part of the mesh, go to the Geometry tab again and down to the Modify Topology tab, and here you have the possibility to delete everything that's hidden. So I delete hidden, right? And now the isolated part is gone. So if I Ctrl-Shift click somewhere next to the model, it does not appear again because we have just deleted, right? And then let's switch back to the Dynamesh tab and remesh the whole thing by hitting the Control key on the keyboard and drawing this little rectangle. And in this case, Dynamesh rebuilds the surface and it automatically also closes any holes, right? So you cannot have holes in it. They will be closed every time you run Dynamesh. This is basically not a bad thing, but it's something that you have to keep in mind when working or when turning meshes into Dynamesh. Then let me quickly demonstrate how Dynamesh handles intersections. So I make sure that symmetry is enabled. I hit the X key on the keyboard and then I go to my brush palette and select the Move Elastic brush. And let's try to make the surface intersect each other. I drag out these guys like so, and then I try to make them touch in the middle here. Maybe we have to do it in 2 steps, and then let's bring these surfaces together in the middle. And if you zoom in close, you can see that they are overlapping each other or intersecting each other. When I now run the Dynamesh command, Dynamesh gets rid of these intersections and comes up with a pretty perfect surface here, right? So this works every time parts of the surface are intersecting or touching each other. So when I mask this bridge for a moment and drag out this portion here and make it intersect with the top, like so, I can clear the mask first by hitting the Control key and drawing this little rectangle. So basically that's the same command that we also use to remesh the model. It clears the mask first and then I repeat the command and the intersections are merged now into a closed surface again, right? So this allows me to create all sorts of openings or holes pretty fast. So if we, for instance, repeat the same with these parts of the mesh, they are now also overlapping each other perfectly again, and I run the Dynamesh command. Dynamesh gets rid of the overlapping, merges everything into a closed surface, and I'm good to go to continue sculpting. Dynamesh also works in combination with insert mesh brushes. So if you go over to the tool palette and look for the insert mesh primitives here and have the cylinder selected, you can simply draw a cylinder to the surface and the already existing mesh gets masked. So we can switch over to or activate our transpose gizmo and make sure that the meshes are perfectly intersecting each other, like so. Then I hit the control key and draw the rectangle to clear the mask first, and then I repeat this command to run Dynamesh again, and then all of our parts are perfectly merged into a closed surface. So this of course also works the other way around. Still with the insert mesh brush selected, I draw another cylinder on the surface, but this time I hit the Alt key to subtract the cylinder from the existing mesh. I clear the mask again, run Dynamesh, and then I end up with this little cylindrical holes. And each time you see these little polygons left over, you can simply hide them like so and go to the geometry subpalette, open up the modified topology and click on delete hidden, and then you can run Dynamesh again, and that gets rid of these floating polygons, right? So basically you can go crazy with your model here. So let me quickly choose another insert mesh brush like the toon brush here, and let's pick the base arm and place it here like so, and then I switch to the transpose tool again, place them in a way that they perfectly intersect with the existing mesh. Next, I clear the mask again by hitting the control key and drawing this rectangle next to the model, and we repeat the command one more time to run Dynamesh, and now our hands are perfectly connected to the mesh. That's all you need to know for Dynamesh at the moment, and let me quickly recap what we have just learned in the last 10 minutes. So Dynamesh can basically be applied to every mesh or every polymesh in ZBrush. So if I go to the tool palette again, click on the tool icon, select a primitive like the cube 3D, show the polyframe, turn it into a polymesh 3D, and then go down to into the geometry subpalette and look for Dynamesh here. I can set the resolution slider to something low like 40, and then activate Dynamesh, and this immediately rebuilds the surface of my model. So if I now hit the X key to activate symmetry and switch over to the move brush, move elastic brush was already selected, and now I can start making all kind of adjustments without worrying about distortions. And every time I run into the situation where I would have to rebuild the surface because I'm stretching out the polygons too far, I simply click the control key, drag the little rectangle next to the model, and Dynamesh recalculates the surface, right? You can go pretty crazy here and create all kind of shapes and intersections fast, right, like so. Keep in mind that Dynamesh requires a closed surface, so if I hide parts of the mesh and delete them like so, and then run the Dynamesh command again, Dynamesh automatically closes any holes and applies a polygroup to them, because it can only handle closed surfaces, right? And it's a great tool to focus on the primary shapes without worrying too much about the topology or what's going on in the background with the polygon model. And when you are happy with the basic shapes or with the overall shapes, you can simply go to the Dynamesh tab again, higher the resolution. Let's try 200. Remesh this guy again and give it 2 seconds to make its calculations, and then we have a lot more polygons available to work with, and then we can start adding finer details with the clay build-up brush, for instance, like so. And another important thing is that we do not have any subdivision levels here, so that means when you lower the resolution again down to something like 40 and remesh the whole thing, or re-Dynamesh the whole thing, then all of the details we have just added on a higher resolution are gone, and you can then pretty much start all over again, right? So for this reason, it's good to start with a low resolution, build your primary shapes, and then higher the resolution step by step. Welcome to the last part of this tutorial. So if you are still watching, you can be really proud of yourself. You have done a great job. Congratulations. And the last 2 hours weren't easy, but I hope you were able to learn a lot. And I will complete this tutorial by showing you how I've created this bird, right? And I'm going to focus mainly on the feet in the next 15 minutes, but the techniques I've used to create them pretty much apply to the entire mesh or to the entire sculpture, right? So we will start with ZSpheres to create a very basic mesh first. Then we turn the ZSphere model into a subdivision model. I will then add some details, turn it into a Dynamesh, add more details, and convert it back into a subdivision model at the end. And we will then eventually end up with something like this. It's a subdivision model with a few levels still intact here and some poly paint on it, right? So there's a lot to cover, and I promise you that when we start combining the techniques I've shown you in the last 2 hours, things will make even more sense, and you will be able to apply these techniques also to your projects later on. Let's get started. I'm gonna start the base mesh of the feet with ZSpheres. We haven't covered ZSpheres yet, so they can be found in the tool palette. If you click on the tool icon, ZSpheres are located in these 3D meshes here. I'm talking about this red ball, and you can simply draw it to the canvas, enter the edit mode like you would normally do with any other 3D primitive. And ZSpheres are a little bit special. So if you hit the A key on your keyboard, right, you get a preview of the mesh or of a little piece of mesh. And if we go over to the tool palette down to adaptive skin, we can set the dynamic resolution down to 0, exit the preview mode. You can do that also here by hitting the button instead of the A key on the keyboard. And if you do so, I end up with a very simplified piece of mesh. And this is exactly what I'm looking for here. So let's switch back to the ZSphere again. And if I hover the cursor over the sphere, you can see that I have this green circle in the middle of my cursor, and that indicates that I'm now able to draw additional spheres on top of our source sphere here, right? And you can hold the shift key, and that tells ZBrush to make the new sphere as big as the source sphere. In the next step, I hit the W key to switch over to the move tool and move the newly created sphere away from the center, right? And if I now hit the A key on the keyboard or enter the preview mode, I can see the mesh that I'm building, right? So let me quickly move this down here. And the current mesh is probably now a little bit too low res, and for this reason I switch back into the draw mode here by clicking the draw button or the Q key on the keyboard, and I simply insert an additional sphere in the middle here by just clicking somewhere in this middle section, right, like so. And when I now hit the A key again, the mesh looks a little bit more defined, and that's exactly what I'm looking for here. So still in the draw mode, I continue adding little ZSpheres at the bottom here, like so. And let's another set of spheres on top of these. I hit the shift key to keep the size consistent. Then I switch back into the to the move tool by hitting the W key, and let's move them in place like so. So what we are doing here is I'm trying to place or position the toes of the foot, right? And then I draw them out like so. That's the middle toe, and both toes at the right. Perfect. And let's place additional spheres in the middle here by just switching back to the draw mode, of course, and simply clicking somewhere in the middle segment to place another sphere. And if I now enable the preview mode again by hitting the A key on the keyboard, you can see that we already have created a very nice low-res base mesh for our foot. So let's quickly adjust it a little bit more. I switch over to scale by hitting the E key on the keyboard. And now I'm scaling down these guys just a tad, also maybe the big one here. And I move these spheres to the side. It's worth mentioning that you don't have to start with these spheres for the base mesh. Actually, how you start really doesn't matter. You can start with a 3D sphere primitive and turn the sphere into a Dynamesh, into a low-res Dynamesh, and start adjusting the mesh until you end up with something like this. But for the feet here, it makes sense to start with Z-spheres because they give me a lot of control, and it's pretty easy to build structures, simplified structures like these with Z-spheres, right? So basically we are already good to go now, and I enter the preview mode one more time to see if everything looks okay. And then it's time to turn the Z-sphere model into an actual mesh. You can simply do this by clicking on Make Adaptive Skin here, and when you do that, it looks like nothing has changed, and that's also true for this tool. But if you go up to the tool palette, click on the tool icon, you can see a new skin Z-sphere object at the very end of this list. So if you click on this, we have now our polymesh available. And in this case, when I hit the A button or the A key for the preview mode, nothing happens. And that's because this is no longer a Z-sphere model, right? And now we can simply start working on it with our tools. I'm switching over to the standard brush. So if you open up the brush menu, the quick menu is available by hitting the B key. There is a way to simply find the standard brush a little bit easier, and that's by hitting the S key for standard. And now all the brushes that begin with the letter S are visible, and the rest gets hidden, and I can find the corresponding brushes a little bit easier this way. So I pick the standard brush here, and of course I have my smooth brush already assigned to the shift key, and now I can start modifying or adjusting the surface a little bit. And because we have set, let me quickly switch back to our Z-sphere model here. Because we have set the adaptive skin density to 2, we already have a subdivision level here, right? So this is the lowest subdivision level, and we already have one level above, level 2, and that's because we have set the density value to 2 before we turned the Z-sphere model into an adaptive skin, right? And you can start here to make your adjustments, like so. Making these toes a little bit thinner, then I switch over to the move brush. And then the inflate brush to slightly blow up the tips of our toes here, like so. And I do not spend too much time on the shapes here, on developing the shapes, because I'm going to make some drastic changes in a second. Because as you now already see, the skin between the toes is currently missing, and we can build that simply by adding a couple of subdivisions first. So I click or I press Ctrl D on the keyboard to add some more polygons to the mesh, and then I go in and simply mask these inner parts of the toes like so. Then I invert the mask. Let's make this a little bit longer here. I invert the mask by control clicking outside the model. I switch over to the transpose tools by hitting the W key, and I have my gizmo here available again, and I can move the gizmo around without affecting the mesh by hitting the Alt key. That lets me reposition only the gizmo, and I place it somewhere like here, and then I rotate the unmasked part over to the middle. Let's give it a try. Okay, let's move the whole thing like so, and I'm exiting the move mode again by hitting the Q key and switch back into draw mode, and then I switch to the move brush is already selected, and I can now try to close this hole here. Let's boost the intensity a little bit and fill in this section, right? And of course, and this is something that you are already aware of, we have just messed up our subdivision model, because if you enable the polyframe, you can see that we have here these ugly distortions and also some intersections, and it's not a good idea to continue with the subdivision model. So now it's time to turn this guy into a Dynamesh, right? So we should then have more polygons available in these areas to continue sculpting, and Dynamesh will also get rid of this intersection here, right? Before we turn the subdivision model into a Dynamesh, it is important that we go to the geometry subpalette and delete any lower subdivision levels, because Dynamesh cannot handle meshes that have active subdivision levels, right? So I go up to the highest level and simply delete all lower, right? So the levels disappear and we are dealing with our high-res mesh here. Then I go down to the Dynamesh, and let's see if the resolution already fits our needs by clicking on Dynamesh. Give it a second to calculate, and if I enable the polyframe again and zoom in, I can see that it maybe already consists of slightly too many polygons for my taste. So I undo this by clicking Ctrl C, and let's set the resolution down to something like 80 and apply Dynamesh again. You have also here these blur settings. I usually set the blur value down to 0. That prevents the mesh from blurring, but you can leave it on the value 2, of course, too, because in this case it's not that dramatic if Dynamesh applies a slight blur. It's a little bit different when you are working on a high resolution Dynamesh and you want to keep all of your details when remeshing the model, right? So I click on Dynamesh again, and now the resolution looks quite okay. We can then simply continue from here, but before I do that, you have probably also already noticed that the model is quite symmetrical, right? So it consists of a right and a left side that look pretty much the same except of the skin here. And we could use the symmetry tool to work on both sides of the mesh simultaneously. So that would speed up the workflow tremendously. And we need to perform a few steps before we can do that, because if I now hit the X key, you can see that the symmetry is off 1 point of my brush is floating around in space here, and that's maybe because the entire model is not positioned correctly in the scene. So I turn off the symmetry mode again by hitting the X key, and let's enable the floor grid by hitting this button over here, and you can see that we are actually having the foot in a vertical position, right? So what I do now is I switch over to rotation and rotate the guy back in place so it stands straight on the ground. You can limit the rotation to 5-degree angles by hitting the shift key while rotating. And this looks already a lot better. So I move it a little bit over here. And I also make sure that the axis here, you can see this little green line down here, the line should be somewhere in the middle here of the middle toe, right? So we have to move the whole foot over to the right just a tad. So I press Alt on the keyboard so that I can move my gizmo or reposition my gizmo without affecting the mesh. Then I zoom in close and move this little guy over so that it's exactly above the axis, right? Then I hit the Q key on the keyboard to exit the transpose mode, and we can also hide our floor again by hitting Shift P on the keyboard. I can now show you another very cool feature in ZBrush, and this is located in the Modify Topology subpalette, and it's the mirror and weld function. And as you can see, it is currently set to the x-axis. You have these tiny little buttons here that you can adjust. I leave it on the x-axis, and when I click on mirror and weld, ZBrush mirrors the left side over to the right, and I end up with a perfectly symmetrical model, right? So let me quickly hide the floor by hitting the Shift P key on the keyboard, and I can now turn on the symmetry mode by hitting the X button or by pressing the X key. And let's also turn off the polyframe, and I am now ready to continue sculpting on both sides simultaneously. So that makes sculpting a lot easier. And it's probably also a good idea to run Dynamesh one more time before we continue. So I control click, draw the little rectangle, and Dynamesh cleans up the seams in the middle here a little bit for me. And the first thing I'm gonna do here is work on the skin between the toes, clean it up. And let's get also rid of these bumpy surfaces here. You can use the smooth tool, or you can also use the polish brush. So if you hit the P key and select polish and increase the intensity here a little bit, you can smooth out many of these bumps quite easily, right? So together with the smooth brush, we will create a pretty smooth surface here. And I do this on the other side too. So the workflow now is pretty simple. I switch between different brushes to adjust the surface, like the move brush, for instance. Or the standard brush to boost some of the details, like so. And we can also take a look at the clay build-up brush. And for the clay build-up brush, it sometimes makes sense to set the intensity to a very low value, like 3 or let's say 5. And then we can use it to slowly build up secondary and already tertiary shapes here. Like so. I can introduce the folds here with the standard brush. And then when you have the feeling that you are running out of resolution, simply run Dynamesh one more time, and this cleans up the surface a little bit, and we can continue adding details, right? Like so. So let's make this guy a little bit thinner here. And the move brush is a little bit too strong. It's also important to mention that you can set the intensity values individually for each brush. So for the move brush, for instance, I've set it to 15 now, and if I press shift on the keyboard to access this move brush, I can set the C intensity value for the smooth brush individually. So let's lower it a little bit, and if I let shift go, I'm back on the move brush again that has an intensity value of 15, and if I press the shift key again, you can see that the smooth brush still has the value of 60 here, right? So you can set intensity values individually for each brush. Bring these closer together here, just a tad. Then Dynamesh it from time to time, and focus on the outlines a little bit to create some nice and solid shapes here, right? So maybe we also have to smooth out the skin at the bottom here a little bit more, and emphasize the shapes with the standard brush. Like so. Okay, it looks already pretty good. Let me try one more thing here. I open up the quick menu by hitting the B key, and then I look for the DamStandard brush by hitting the D key. It's this brush here that lets you carve into the surface like so. And I'm trying to make this area here a little bit better. And I build up some of the shapes at the top with the clay build-up brush. All right. Looks okay. And because it already looks quite good, now it's time to turn the Dynamesh back into a subdivision model again, and you already know how to do this. So I go to the subtool, sub palette, and duplicate the current model, and as I'm already in solo mode, only the selected layer is visible, and I also make sure that the symmetry mode is still active. So when I go down to geometry and open up the ZRemesher sub palette here, the ZRemesher takes the symmetry into consideration. And let's enable the legacy mode again and set the target polygon count to something really low, like 0.6 for instance. And then I click on ZRemesher and give ZBrush a few seconds to prepare the mesh for me. And we then eventually end up with a perfectly symmetrical, clean, low-res base mesh, right? So let's switch between the original and the new one. And I think it did a great job. And I'm not going to project any of the details from the Dynamesh back to the new base mesh, because this would also project all of these little imperfections, and I would have to clean them up later on again. So the only thing I do here is I select our new base mesh, open up the geometry sub palette,
and then add a couple of subdivisions. And you can do that by simply hitting Control D on the keyboard a couple of times, right? And then we are basically good to go to finalize this sculpture. So I switch to the standard brush again, lower the intensity a little bit, make sure that I'm still in symmetry mode here, and then I continue sculpting and refining the mesh like so, right? So again, I'm switching between different brushes like the standard brush or the move brush. M for move, and then let me select the move brush again. And we are now really working on the fine details here of our model to make it look smooth and perfect. Let's also emphasize the skin and the toes at the bottom here a little bit more. Like so. I'm also adjusting the radius of the brush on the fly by hitting the S key and moving the cursor up and down. And let me quickly switch to the move brush again and adjust the thickness of the middle toe. Like so. Perfect. I'm still not that happy with this area here, and that's probably because I don't like how the leg is bending, and because I have subdivision levels, I can step down to the lowest level by hitting Shift D on the keyboard a couple of times until I reach level 1 here, and now I can mask the leg like so. I blur the mask by control clicking on it. Then I invert the mask by control clicking next to the model, and I activate the rotate transform tool, and we can reset the orientation of our gizmo by hitting Alt on the keyboard and clicking on this little reset orientation button, and then I move it in place by still keeping the Alt key clicked. And then I can rotate it like so. And we can also move it a little bit. And that's of course a lot easier when you have a model that consists of subdivision levels, because I do these adjustments on the lowest level. And then let's clear the mask by hitting the control key and draw this little rectangle. Step up the subdivision levels by hitting the D key. The move brush is still selected, and then I can adjust the shapes of the leg a little bit more, like so. Let's move out this area a little bit more, and maybe adjust this shape and make the crease a little bit deeper with the DamStandard brush, like so. Perfect.
All that's left now is to apply some colors, and you can simply do that by choosing a base color here. So let me try to find a nice orange color like so. And then I go to the color palette and click on fill object to fill the entire object with the selected color. We can also switch to a material that's a little bit lighter, like this one. Then I select my standard brush again, turn off C-add and make sure that only RGB is enabled. We then choose a slightly lighter orange and start painting in some highlights at the top here of the toes. And we can also maybe make the skin between the toes a little bit darker, like so. It's probably already too dark. Let's try this. It looks a little bit better, right? And let's do this at the bottom too. And we are still making use of the symmetry here, because I only have to work on one side of the model, and that makes things a lot faster, of course. And you can always sample colors directly from the surface of the model by clicking on this little color swatch, and then keep the mouse button clicked and drag the cursor over to the surface to sample every color that's below the picker. So I pick the light orange again and apply it also at the bottom here. That was maybe a little bit too much, so I lower the RGB intensity. Right. And that's basically it. We are done. One last adjustment here. Right. Looks quite okay. I was applying the exact same method to the other parts of the bird, like the body or the beak. So for the beak, I was starting with a simple sphere. I've turned that sphere into a Dynamesh with quite low resolution. Then I was trying to define the primary shapes with the standard brush and the move brush. And when I was happy, I turned the Dynamesh into a subdivision model again. And all I had to do then was cleaning up some of the shapes and applying some colors, like we did with the feet, right? And for the body, I started with a sphere for the head, and then I literally drawn the entire body out of this Dynamesh sphere. And when I was happy with the primary shapes again, I was turning it into a model with subdivision levels to define the primary shape even more on the lowest subdivision level, and to add smaller details and poly paint on the highest subdivision level. And that's basically it.
So that's it for this tutorial. Thank you very, very much for watching. I know this was not the ordinary quick and easy YouTube tutorial, but I still hope that you were able to follow along and that you are now a little bit more prepared to continue your journey to become a CG artist. I publish videos like this every week, so subscribe and don't forget to hit the little notification bell. And even more important, leave a comment, give me some feedback and make suggestions for upcoming videos. So see you in the next one. Cheers!